So I'm going to try to demonstrate a little bit of calibration setup of the rotor system and why the calibration is important. I had to do it on a recording because I got to splice different videos together to get the whole picture. And it's the only way I could see doing it. I don't have the capability to do it live. But right now you see one camera is pointed at the rotor itself, and I got a little piece of cardboard in there simulating the direction the antenna be facing. I got another camera on the controller. The top is an interface made by a ham in Portugal, and the bottom part is the Yaesu G-5500 controller, which goes with the G-5500 rotor. And it's got some nice features, but it doesn't have computer interface, and the accuracy and / speed isn't perfect, but it is a really good system, and it's pretty much plug and play. But you need a computer interface. That's its drawback. So to have the computer interface, you have to have something. One thing Keith had was this thing called the I'm going to forget what the name is. I want to say lib board or something like that. Essentially, it was just a generic interface that somebody else did some hardware to create a interface for the Yaesu system. And so this is sort of another version. There's a ton of them that do the exact same thing. They're an interface between the computer and the Yaesu controller, and they operate off USB off the computer. Now right now it's about to start moving, I hope. I've set up a satellite coming in view on set PC32, and at the top, if you remember my other video, I've got
satellite range B rising.
There it is, range B satellite. So it should lock in here in a second. I think I need to do a setup. So here you go, live TV, right? If need be, I can edit this part out. But the serial port wasn't up when I started the program, so I just need to restart it. That's one thing with SAT PC32 is numerous times as you're running the program, you're going to have to restart it. Just the various settings and whatever, things always have to be restarted. So let's see, there it is, live, and turn on the thing. There we go. So now you can see the rotor is turning. I was wrong. I don't have that set right for the angle. Let me adjust my antenna slightly. Pardon my reach. There we go. I took a guess at what 0 was. So you can see right now it's commanding 0 or 2 degrees elevation at 316 on the azimuth. And as the satellite moves, it's calculating an update. And it'll do that for the duration of the pass. And you can kind of tell, you know where the elevation is going to be based on how far you are outside the footprint. And you can see the little X on the SAT PC32 screen. The little X, the big X is satellite. The little X is our position, roughly. I just kind of quickly typed in the Latin long. Actually, I take it back. This should be the actual correct Latin long. So it's calculating based on that position, Latin long position. It's calculating where it has to point the antenna, the rotor, to point at the satellite. So since we're at the far fringe, the very edge,
armadillo rising,
the edge of the footprint of the satellite, it has to point towards the horizon. Now the software has capability to put multiple satellites in view. So see if you show me the other one. For some reason it doesn't always work. But I'm going to just quick switch over to the armadillo and see where that one's pointing. Okay, so that's an opposite pass. That's a low pass. So the other one was high pass. This is a low pass. But again, if you look at the rotor, its control is commanding 171 degrees and on the horizon again. And so guess what? The rotor's turning. And hopefully I've put enough clearance in there where I put that piece of cardboard where it won't drag. It's going to be close. This is which way it turns. I had to put the drop cloth in here because it's so dark. My drawers are dark. Against the dark rotor, you can't see it. But you can see how it's turning. It's just pointing towards the satellite, towards the horizon, trying to make the pass. Now, as soon as it gets done with this pass, I'm going to show you the alignment and why the alignment is the most important thing to the whole deal. So let's give it a couple more turns, and then I'll just stop. If you look at the Yaesu display, you can see again showing 0. And if you look at the needle, it's halfway, and roughly, well, just past halfway, about 170 degrees or so. But you can tell the far left end is a stop, and it's 360, and the far right end is a stop at 090. And if you do some quick math, you realize that's more than 360 degrees. So it's actually, in this case, 450 degree turn. So go from straight east all the way around past, straight north, all the way around past north, back to east again. And I think they do that just to give a little more room for it to track without having to reset every time. So in my practice, I've been playing this thing, I've never had it not track correctly. It kind of just knows where the whole path is going to be, so it calculates based on that where it needs to start. The software on the computer, you tell it where north is on your system. In this case, you can tell the Yaesu system is designed for north, right? So its endpoint is north. It's designed to be a north-facing system. For whatever reason, if you're a real south hemisphere, you may set it up differently, but for us, the north system is going to be good. Eventually, I'll show the other controller, and you'll see that that's kind of a different way of looking at things. But right now, I'm just going to deal with the Yaesu. This will be the portable setup, and this is the one that kind of will need help in the setup because every time we take it out of the box, figuratively, we'll have to realign the whole thing. So let me stop this pass. I do that by just turning off the rotor control. Now, the whole time, we always have access manually. So the initial setup is you want it full down and full left. And my cardboard is going to be a problem. Again, the cardboard's there so you have something to look at. Because some of the stuff doesn't make sense until you put it in context. So, it's full left, it's full down, 0, so 0 elevation, full left, in this case it should be pointing straight north. And I've made a mark on the bottom of on the azimuth part of the rotor. I made a mark on there on the north side so that it's always going to be north. And I had to come to this conclusion because the rotor, and I'll show this, when I go up, it only rotates one direction for up. And you can see it is going up. Well, if I had this cardboard on the other direction, on the other end, pointing opposite direction, instead of going up right now, it would be going down. And guess what that means? That means you don't have it pointing north, you got the antenna pointing south. So I made a couple markings on here just to make sure it started out correctly. So the rotor says this end should be north, so the azimuth part of the rotor says this end is north. I wrote on top a little arrow pointing north so that I always know that is where our north calibration position is going to be. Now, part of the reason I'm bringing this up is the rotation is based on this starting point. And if you look right now at the elevation cable, you can see it's wrapped around the rotor body, right? And that's part of the design. It has to be able to wrap around. Well, you need to know where the end is to know where the end of the wrap is. Otherwise, you get a full rotation edge and you just unplug the rotor, you've broken the cable. So we have to start this position. So the first step will be in going full down, full left on the controller. So now that we know the rotor is where it needs to be, and then from there we just physically point the rotor where we want north to be. And we'll use magnetic north, and so we'll need a compass, but once we have an idea of where that is, it's not going to change after we initially set it in place. So we set the tripod in place, we make sure we're full left, so we have to be powered on and no antenna attached for obvious reasons. Pointed north, make sure it's rotated full down and full left, and now we have a starting point. And we have to do this with the antennas off for obvious reasons. One is it's kind of a pain to move around the antennas, but the second part is if I had this rotor, if I had the antenna mounted backwards, right? We forgot, and we've seen this happen. Let me fix my antenna in a real second. There we go. And if you've helped during the setups, you've seen this happen where you think the thing's all set up correctly, but it's actually backwards. So now, if I think that is the correct position for the antenna, before I've done any tests, and I go to raise it to check 90, well, guess what? I just drug the antenna into the dirt, right? So that's why I got to make sure full zero, full left, and now I know starting point. And I also made some marks on there so that keep track of what's what. And like I said, the cardboard's in there just for your guys' benefit. But on the actual setup, you want somehow to indicate the top and the forward position when you're doing your checks, so that when you mount the antennas, you mount them correctly in the correct position. Easy mistake to make. So if we check the rotation, and I'm going to spin it right, and depending on the software, I'm trying to think what software required it. But I want to say it's the software user with Keith system. Keith's controller.
Satellite 0.1 rising.
Ignore that guy. You'd actually do a couple checks. You check at the full left position. You check at 9 degrees up, and in our case, 225. And why 225? Well, guess what? That's the halfway point. So about 90. It's pretty close to 90 on the thing, and not quite 225. And it just happens to have a mark right at 225. So this would be the second calibration point, showing your midpoint. So that's for the software. Again, that's the other controller if we have to use that one. This one, I did all the calibration in the box itself, and it should maintain its calibration. You can kind of see this saying, this is where I'm at, 226, 086. Yeah, it's pretty close to 090, 225. And that would be setting your midpoint, and then you want to set the extreme. On this piece of hardware, it wanted to know the no kidding extreme of the system, so I had to go to the 180 mark so to know what the full scale was. But on the other software, the other hardware controller, Keith's system, you had to go to wherever your planned limit was. So if your planned limit was 90, then you stopped it at 90, so that it knew where that was. And then the last is you check, you go to the endpoint, and this is where on the other software you just change the right rotation. And this calibration's already been done. But you do this step anyway because you need to make sure you still have enough cable for the whole sweep. And when you get finished here, it should be pointing about 090 again. And we'll want to secure the cables a little bit better than I have. They're just there temporarily. I only have about 3 feet of cable attached to the rotor. But now you know we've got this whole sweep. Again, only the elevation cable moves. We've got this whole sweep and nothing's bound up, so it's all good to go. And I've actually done this point. If you look on the little display, I don't know if it shows it, but it says 447 and again 086. So it's tracking very nicely. This little box should maintain its calibration all the time. I'm including the instructions with when we store it away, in case for one reason it gets stupid, you have to recalibrate. But it's supposed to maintain its calibration in EEPROM and never deal with it again. And it's always calibrated for a Yaesu system. It understands that setup. So I think now you can kind of see why we need to know where north is, and we need to know where the limits are for the cable control, as well as to make sure we got the antennas pointed the right way. So that would be the first part. Now I've kind of get to the software, and I started up just kind of fiddling with it. But I've come over here to the software for this particular box. There's two things we'll have to set up overall, but this particular box requires this Saber track box, S-A-E-B-R track box. Now in here, the first setting doesn't matter. The second setting really doesn't matter. So these are the defaults, and the turning point should already be in for north, and that means in our case north is going to go past north, right? So ours is north. We're set up that way, so that's the default. Minimum elevation, it doesn't really matter. Ours has limit switches, so once you go past -3, but that kind of allows for a little bit of slop, so that if this gets a little bit out of adjustment, it'll still just go to the limit switches, even if it's a little bit off on degrees. The lower points, updates at satellite position change, or at every so many seconds. Right now it's set for time intervals, so every 10 seconds doing an update, and this is set position change, how many degrees change. Or 5 degrees it'll change, or if you really want to be precise, you put in a degree and it's going to bump every degree. Now here, this is a default setting. This does need to be set no matter which system we're using. We use 9 degrees, right? Because we don't want to deal with the antenna going over upside down. For a lot of reasons, there could be polarization issues, but also it's just good planning. Otherwise, you just get confused. And it doesn't need to go past 180 because you can simply rotate the rotor and bring it back down again. So even if it's doing a direct pass over the top, it'll just spin the rotor and then lower back down again very gracefully. And we mentioned that the Yaesu is a 450 degree azimuth rotor. So the 360 back around pass to 90 again, 450 degrees. So that means the computer program knows that that's the kind of rotor we have, and it will track properly. There is no, for this controller, other than that, there's a setup right here where you have to do the COM setting. So the first time you plug in a computer, it will ask you for the COM setting. All right, so you got to go into Device Manager, figure out what COM port has been added, and it's actually labeled differently than any other COM port, so it should be obvious of which one it is. And I guess I can show you on mine, and you realize the clutter of the SDR software in there has all these extra ports, right? The flex radio ports, but down here, right there, USB serial CH340. So it'll always be called that. So it's like, okay, it's that one. So my case, it is port 13. It's always supposed to be 9600 baud, and again, these are in the paper instructions. And the rest of this, I think these are all defaults. If not, it asks you to set 10 milliseconds for pacing delay, and I think that's just a COM delay between when it sends an input and when it sends a second input. I don't know if it makes a difference. I just set what they said to set, and press on with it. So no satellites in track right now. The second setup would be your radio, and I don't have the radio connector right now, but we're using the Yaesu 847. This is kind of interesting how it sets up, but you'd have to figure out what COM port it is, right? Set it in CAD delay. I think 30 is the default, and that's a good number for it. COM port, again, you have to look at the adapter, right? We have a serial to, I think it's a USB serial adapter. I can't remember which one it is, to the 9-pin serial cable plugged into the 847. So once again, you have to check your devices, see which COM port that one is, and we already know what this box COM port is, so you have to see what that COM port is, and then set that one for the radio. Also in here, so there's two parts. The 847 is under Yaesu only. We don't run a second radio, so it's just radio 1, Yaesu, model 847, and whatever the COM port is, satellite mode. But there's a second drawdown, pull down we have to look at, and that's baud rate, and we'll set 57.6 for that one. And if you need to change the baud rate, I don't remember what the default was, but you need to set that, and because that's what's set on the radio is 57.6. All right, so you got to match up. I believe that's what's on the radio. But when we power up the radio, there's a menu button. You can actually push it, and I want to say it's menu 37. It shows the baud rate, but we want 57.6. It seems to work really good. For Comport, you can see what it is, but the way it adjusts is you type in the second window. So with the Comport it is, you type in the second window. I could have hooked it up for the demonstration, but I don't have antennas, so it doesn't do any good. And of course you store that. And any change you make on this program, you have to close out and restart. Anytime you have a problem, you're going to close out and restart. You think it's not tracking right. What are you going to do? You're going to close out and restart. Simplest answer. And you saw it's really fast, it's shutting down. It just sometimes gets dumb. So I'm not going to wait for those guys. Let's see what else I can find. There's ways you can pull them in. There's some groups in here. See if any of these are up. No. I had a whole bunch earlier. I guess it must be break time. No. And you can see here on the timer how long it is before the next pass. And I've been doing passes all the time, but it's a matter of where where it is. Yeah, geostationary. That's an easy one. Oh, there aren't any there.
Satellite Nasat 1, Fresco, rising.
All right, so I know you use rising, right? So it's top on the list. It's in track for 8 more minutes before it goes to LOS. So I click on it, and I turn on tracking. It tracks. All right, now it's showing the multiples. So you can see that if you have numerous satellites on there, and I'm not sure what's criteria is, but if you go to multiples, it will show all the different satellites that are, maybe it's the last 5, so 1, 2, 3, 4, 5 perhaps, but it's showing their orbits, or better yet, their footprints, their current footprints. So you saw the thing spun all the way around to correct itself. It's pointing 310 to 015. I'm going to let this one go till it's finished, because what you'll find out is after a period of time, if you haven't selected another satellite to follow, it's simply going to park itself at 320 and 20 degrees up. I'm sure there's a good reason why that's the default. Maybe because it's equidistant between all the trackings, so it's a shorter distance once you reacquire. But that'll be the last thing it does. It'll stop tracking, it'll wait a little bit, and it'll park itself. Something to keep in mind when you're doing things, right? So anytime if you decide you got to do an adjustment on the antenna or something like that, and you're not actively tracking, you may forget that it's going to park itself. So make sure you turn off tracking, which again is right up there, the R+. Turn off tracking, and that's really turning off rotor control, I should say. Turn off rotor control, and now you can manually set it using the knobs to whatever you need. You just need to lower the elevation to check it, or you're doing some other adjustment. We'll let this run for a little bit, 6 minutes worth. So you can expect that I'll fast forward for a little bit of this. Okay, about a minute before loss of signal. Something I hope you recognize is that the importance of the calibration and angles is really critical because we're dealing with weak signals. That's why we have preamplifiers on the antennas, and we're trying to point it directly at an object spinning past the Earth. You know, it's like when I talked about the Patriot missile system. You know, it's hitting a bullet with a bullet. So any deviation just compounds itself once you get, you know, thousands of miles away. So we'll have to, critical is north, critical is 0 and level, so we'll have to have a level for that. And basically, once we get the antenna mounted, we have to make sure they're level. But also got to make sure they're square. So we'll have to have a square with us, or some way to measure to make sure that the antennas are square to the direction of motion, square to the antenna rotor shaft they're mounted to. So they got to be perfectly level, perfectly square, and then clamp down so they don't move. And that's probably the critical part, because we can do all this stuff with the software and all that, but if it's aimed wrong, it's going to track something, but there's no feedback loop. It doesn't go and recognize a little bit off based on audio from the machine. And now it's moving to the 360 at 20. I'm sorry, 300 at 20. So there's part. So that's why I'm kind of bringing this up so you guys understand the basics, and that's why the critical part is going to be the setup. Again, north alignment, once you get the antennas level to the horizon, level to the earth, mounted safely, securely, and square to the path, right? So once you've done all that, now we have to have some way to route the cabling, right, the coax to them. So the best way I think to do that is sort of like I showed and mentioned in my write-up is you have to rotate it all the way to the left, and run the coax the same direction the rotor cable goes. So now you know that's a good good direction to move. We'll have to secure them obviously, but that'll give you your plane of motion, so it's wrapped around the same way that elevation cable is. And then you have to make another pass, and the safest way to do this would be, again, before the antennas are mounted, just with the coax mounted, do a rotation all the way to the right, to the full direction, to make sure that you don't have any stretch of the cables. So they should be able to track nicely without getting hung up or stretched. And then once all that's good, now I'll mount the antennas, hook up the coax, and again, before we commit, where you got everybody watching, do some manual adjustments to full up and the left and right, and make sure nothing's binding and the thing's going the correct direction. And why? Because once you go to auto mode, it may start doing the wrong thing, and you won't if you haven't already planned for it and made sure it wasn't working right. It's going to plow it in or wherever it is. So, hope that's the key takeaways of this whole thing. I think it's very interesting. The ground setup isn't this hard, right? I've kind of showed you this whole thing. That's the entire setup. The calibration is mostly done. So the hard part will be once we get the antennas mounted and getting all the alignment done. But as far as the tracking, that's done automatically based on predicted position. All right. So in the future, once we get the SPID controller fixed, it has some bad relays. It's a trend item apparently. Then I'll do the exact same thing with the SPID rotor, and that's a different setup, and so it's going to require different information, different calibrations. But hopefully that makes sense to you. And as always, any questions, you can direct them to the group's IO page.